There's no more class?
Well, yeah, this is the last day of class. The thing is, tomorrow y'all have the final exam, right? Oh, yeah, and we're going to go over that from the 3 to 4 hour.
And Thursday?
And then Thursday, I'm not going to see you because you'll be done with logic.
What about next week?
Thursday, you'll be taking your engineering final and your problem-solving final.
How long? Wait, so the final's going to take all day?
The final will take 2 hours. Yeah. Yes, ma'am.
I didn't get a review because I was here yesterday.
Okay, I'll get you one a little bit later. Okay. All right, so I'm going to declare a couple of sets here. So I'm going to say that set E, actually, I'm going to declare my universe first. So the only things that I'm going to be considering in my universe are the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. That is my universe sets. That is everything that I am considering, everything that I'm dealing with here in this. Yes, sir? Okay. So I'm going to say set E is going to be the set of even integers. So tell me what it means to be even. Divisible by 2. So 2 and 4 and 6 and 8 and 10. Okay? And I'm going to let the set O represent the set of odd integers. That would be what? 1, 3, 5, 7, and 9. I'm going to let P represent the numbers 2, 3, 5, and 7. Keep in mind that this is supposed to be some type of predicate. So if E represented the predicate is even, O represents the predicate is odd. What do you think P represents? What do those numbers 2, 3, 5, and 7 have in common?
Well, 2 is on the even side, but 3 is on the odd side.
True. It's a mix of even and odd numbers. So it must be something that doesn't have anything to do with even or odd.
2 plus 3, 5 plus 2.
2 plus 3 is 5. 2 plus 5 is 7. Interesting. What if I told you that set C contained the following numbers? 4, 6, 8, 9, and 10.
Prime numbers and P will be prime numbers.
P is prime, that's right. These are prime numbers, 2, 3, 5, and 7. And what about 4, 6, 8, 9, and 10? They're composite numbers. Okay? And remember that 1 is neither prime nor composite. So these are the sets that we're going to be working with in today's exercises. So what I want to do is I want to deal with these sets. So I want to talk about what is E intersect P. Remember that intersection is the elements that they have in common. So what do these two sets have in common?
2.
2?
That's it.
And that's it. So the intersection of these two sets would just be 2. What about E intersect C?
You would have 4, 6, 8, and 10.
4, 6, 8, and 10. And what about E intersect O?
That would be nothing.
It would be nothing, right? Because there's no number that's both even and odd. So we would say that this is a set that contains no elements. And we actually call this, when it happens, an empty set. So an empty set is a set that contains no elements. And sometimes, because we're even lazier than that, we'll just draw a 0 with a slash through it to show that we're talking about an empty set. How about O intersect C?
That would be 4, 6. Oh wait, no, that's O.
Yeah, what do O and C have in common?
It'd just be 9.
Just the set containing 9. Okay, and remember what I said yesterday, if you're having difficulty drawing these braces, you can just draw a bracket with a little mark on the side. That might be a quicker way to do it. But yes, you do need to draw braces. So intersection is what they have in common. Keep in mind that when I'm doing an intersection, I should end up with a set that is the same size or smaller. notice that all of these sets are smaller than the sets that we use to get them. Intersection is an eliminating process. So the results should be smaller or no bigger than the original sets. The other thing that we talked about yesterday was union. And remember that union was like putting things together. It was an or situation.
But not repeating.
Right, and I don't want to repeat because I just want to know what elements are either even or prime.
And
Keep in mind, what we were talking about yesterday is we were talking about intersection being an and. So what number is both even and prime? Only 2 is even and prime. What number is odd and composite? Well, only 9 is odd and composite. But if I want to know all the numbers that are either even or prime, that means I want to take a look at this even set, take a look at this prime set.
And you would get 2, 3, 4.
2, 3, 4, 5, 6, 7, 8, and 10. Why is 1 not in this set?
Because 1 is not a prime or even number.
1 is neither prime nor even, right? And why is 9 not in this set?
Because it is not prime or even.
It's not prime or even. It's neither prime nor even, right? Notice that when I'm doing unions, I usually end up with larger sets, or at least sets that are no smaller than the starting sets here. How about if I have P, actually not P. Let's do O union P. So if I want to take set O, which is my odds, and P, which is my primes, what do I end up with when I take the union of those sets?
You get 1,
1,
2,
2,
3,
3,
5, 7, 9.
5, 7, and 9. And the order doesn't matter. If you wanted to say that this set was 1, 3, 5, 7, 9, and 2 is the only thing that P contributes, that would be fine. What's important to note is that when we're talking about sets, the order is not essential. It doesn't have to be in a particular order. We do have to get rid of repeats, though, so I don't want to put 3, 5, and 7 in there again. So this is what we talked about yesterday, right?
Mm-hmm.
Okay, so there's a couple of other things that I want to talk about today.
Complement.
I want to talk about complement. And the complement is the set of elements not found in a given set. Okay, a complement is the set of elements not found in the given set. So when I ask you for the complement, and by the way, we're using a cursive C for complement because otherwise C is composite, right? If I want to know the complement of the evens, I'm asking you to tell me all the numbers that aren't even. So what's not in set E?
1,
1,
3, 5,
3,
7, 9.
5, 7, and 9. Now, does this set look familiar?
Yes, it's the odd.
This is the set O that we had up here, the set of the odd numbers. And similarly, I can ask you for the complement of the primes. So tell me what numbers are not prime. 1, because 1's not in P. 4, 6,
7.
well, 7 is prime, so no. 8, 9, and 10. And notice here I'm asking for the complement of the primes, and I end up with...
Composite.
Actually, I don't end up with composites because what's missing there? 1. So when I'm talking about the composite, when I'm talking about the complement, I'm talking about everything that's not in the original set. So any questions about complements? Okay. So the other thing I wanted to talk about today was set difference. So difference is the set of elements found in the first set and not in the second set. Okay? The difference is the set of elements found in the first set and not in the second set.
So you would keep the first one, and you would
Keep the first one,
take away the second one.
and I take away stuff in the second
so
set.
If you had E and E minus P, that would be E minus P.
Okay, so E is 2, 4, 6, 8, 10, and I want to take all the primes out of that set.
So
What numbers am I going to take out of this set?
You would take 2.
2?
You would take, you would take not 6, you would take not 8. Wait. You would take
I would
8.
take 2 away.
You would take 2 and 8.
Can't take a 3 away because 3 is not prime, or 3 is not even, I mean. I can't take a 5 away because 5's not in that set. I can't take a 7 away because 7's not in that set. So what are the only numbers that I took away?
2 and 8.
Well, 8 is not prime, so I can't take it away. I'm saying E minus P, I can only take primes away.
So it'd just be 2.
So 2 is the only thing I'm taking away, so what's left?
You've got 3, 4.
Well, no, I'm only looking at E. I'm taking 2 away, so what's left?
4, 6, 8, 10.
4, 6, 8, and 10. P minus E. Now I'm saying I'm looking at my prime set, and I'm taking away all the evens. So my prime set is 2, 3, 5, and 7. What even things am I going to be taking away? 2. So what's left?
3, 5, and 7.
3, 5, and 7. That's interesting. That E minus P and P minus E aren't the same. But then again, we expected that because 5 minus 2 is what?
3.
3. And 2 minus 5 is?
3. Oh, wait, I'm not going to get
Negative 3. So the thing is, we get different results from subtraction. I want to go back to the definition of this because this is interesting. It's found in the first set and not in the second. So in other words, the first part is true and the second part is false. This certainly looks a lot like the conditional. First and not second. This is the situation where my mom lies to me. This is the only situation where a conditional statement is false, is when the antecedent is true and the consequent is false. So in other words, the set difference really corresponds to a conditional, similarly to how a complement is dealing with a negation. So the thing is, we talked about how an intersection was like a conjunction yesterday. We talked about how a union was like a disjunction yesterday. And today we're taking care of the other 2 major set operations that we were dealing with, the 2 logical operators that we talked about earlier this summer. So we talked about negation, things that are not in a set, and then we talked about conditionals. We talked about set difference. So I want to do some more examples of this set difference. So what if I was to take C minus O, the complements minus the odds? Okay, and what's important to remember is that I'm starting with this complement set. So I'm starting with C. And I want to take away anything that's odd. So what am I taking away?
9. Oh, wait, 8. Wait, no, 9.
Yeah, 8's not odd. I'm taking away 9 because 9 is odd. So if I was to take away 9, what would be left?
4, 6, 8, and 10.
4, 6, 8, and 10. If I were to have O minus C, I'm taking the odds minus the complements. So if I'm looking at odds, What's composite that I want to take away? 9. Okay. 9's the only composite that I'm going to take away. So what's going to be left? 1, 3, 5, and 7. So I'm going to do a couple more examples. I'm assuming you have those sets written up at the top. What is O minus P? First, tell me in words what that means. What does O minus P mean? The odd set minus the primes. Now, what's in the odd set? Right, but what numbers?
1, 3, 5, 7, and 9.
1, 3, 5, 7, and 9. And I want to take the primes out. Which of those numbers are prime?
3, 5, and 7.
3, 5, and 7. So if I'm taking those numbers out, what are the only numbers that are left?
1 and 9.
Okay. Why is 1 left? It's not prime. Why is 9 left? It's not prime. If I was to do P minus O, now I'm taking the prime numbers and I'm taking the odd numbers out. So what numbers are the prime numbers? 2, 3, 5, and 7. And I'm taking which numbers away?
3, 5, and 7.
3, 5, and 7, so that's leaving 2. Please notice that when you do set subtraction, you end up with different answers depending on the order. The first set is the set you're starting with, and the second set is what you're taking out of that first set. So the set subtraction should be no bigger than your first set. It should contain elements in your first set, and you're never going to add stuff to it. If you're doing subtraction, you're never going to add to it. And that's an important point I want to make. So, we've done examples using numbers. But what we talked about yesterday is that sets are predicates, so we really could use anything. So, I'm going to create a new universe over here. So I'm going to tell you that my universe is going to be the set containing red, orange, yellow, green, blue, indigo, violet, black, and white. So this is my universe. It contains red, orange, yellow, green, blue, indigo, violet, black, and white. Now I'm going to have a set called A. It contains the following colors: red, white, and blue. Because what's red, white, and blue?
America.
The American flag, right? I'm going to create a set called R, which is going to contain red, white, blue, horrible Potter, bad Potter. Red, orange, yellow, green, blue, indigo, and violet. So what does R represent?
Rainbow.
That's my rainbow, right? And I'm going to have a set called N, which is going to contain blue, indigo, and violet, and black. And those are the colors of my night sky. Because my night sky is blue or indigo or violet or black, depending on where the sun is past the horizon. So I can look at these sets, and I can ask you about these sets. Tell me about the complement of A. What's the complement of the set containing red, white, and blue?
It would be orange, yellow, green,
Orange,
indigo, violet, and black.
yellow, green, indigo, violet, and black. In other words, all the colors in our universe that aren't on the American flag. Does that make sense?
Mm-hmm.
What about the complement of R?
That would be
It'd be black and white, yeah.
yeah,
Why? Why is it black and white?
because those are the only two colors that aren't on your rainbow.
The only two colors in our universe that aren't in our rainbow. And if I wanted the complement of N?
You have red, orange, yellow, green, black.
Red, orange, yellow, green, and white. So they're the only colors that aren't in our night sky, according to the set that we have. So any questions about complements? All right, what about A intersect, B and A intersect R?
Red.
Red are in both
And
sets.
blue. Red and blue.
Blue are in both sets. Does that make sense?
Yeah.
That's where those two sets overlap?
Yep.
What about R intersect N?
Blue and
Well, where do blue and
indigo, and violet.
indigo and violet? Does order matter if we're doing intersection?
Yeah. No.
Yeah? No?
No.
Which?
It doesn't.
I mean, if I was to do N intersect R,
Blue, indigo, violet.
it would still be blue, indigo, and violet. Those are what's in both sets, right?
Uh-huh.
Okay. All right, so how about A intersect N? What does the American flag have in common with the night sky?
Blue.
Blue?
Blue.
Anything else?
No.
That's it. So intersection, we know, is what those two sets have in common. How about A union R? What happens if I take the American flag and the rainbow and smush them together?
We have red, white, orange, blue, yellow, green, indigo, violet.
Okay. So we got red, white, orange, blue, yellow, green,
Indigo, violet.
indigo, and violet. What's the only color that's missing from our universe here?
Black.
Black's the only color that's missing from our universe. How about if I was to take A union N? Red,
Blue, indigo, violet, and
white, blue, indigo, violet, and black. So I've got all these different colors. Any questions about intersections or unions?
Nope.
Okay. So how about A minus R? Keep in mind, how many colors are in the American flag?
It would just be white.
3. And I want to take away from those 3.
It would just be white.
It would just be white. Now, I want to draw a comparison between what we just did with A minus R and A intersect R.
From A intersect R, and red and blue is missing from the A minus R.
So in other words, these two sets together would make A, right?
Uh-huh.
And the thing is, the intersection and the difference are related in that way. The difference is always going to be what's missing from the intersection. The intersection is always going to be what's missing from the difference. So that's another way that you could think about this. So if I was to do A minus N, take the American flag and subtract the night sky, what colors would be left in the American flag? Red
Red.
and white. Because the intersection contains what?
Blue.
Blue.
But wouldn't it depend on the order
you put
It would depend on the order. You're absolutely right. If I was to take N minus
What would it
A,
be like that?
I'm going to take a look at the night sky. The night sky contains blue, indigo, violet, and black. And what am I taking away? I'm taking away blue, which leaves what? Indigo, violet, and black. Notice the only thing that they're missing is this blue. Blue, indigo, violet, and black gets me back to my original set N. So it still has that relationship. It's just now the relationship deals with set N, not with set A. Similarly, I could talk about what R minus A is. What happens when I take the rainbow and subtract the American flag?
Minus A, you would have
Orange,
orange,
yellow,
yellow,
green,
indigo, violet.
indigo, and violet. Because I'm missing red and blue from my rainbow. So set intersection and set difference are still related to each other. Does that make sense?
Yes.
So any questions about the set stuff? That's going to make this homework assignment that I asked y'all to do yesterday a little bit easier now, right?